Today we're going to be graphing quadratic functions that are non-factorable. So before, we would use factoring and the zero product property to find the x-intercepts of the parabola. But if it's not factorable, we need another tool to help us find some important points so that we can graph the parabola doing the least amount of work. So that special little tool to help us is that our axis of symmetry and the x value of our vertex will equal the opposite of b over 2a. So I read this symbol right here as the opposite, and I put that with the numerator. So a is our x squared coefficient, and b is the x coefficient. So those are the numbers we'll use in this formula. X equals opposite of b over 2a. So taking a look at example 1, if I multiply a times c, -1 times 6, I would get -6. There's no factors that would multiply to -6 and add to -4. So this quadratic is not factorable. So what I want to find first is the axis of symmetry and the vertex, because that's probably the most important point. And then having the axis of symmetry allows us to reflect points across it, so we get twice as much information for one calculating. So a would be the number in front of x squared. It's an understood -1 when you have that negative here. B, the number in front of x, is -4, and c is 6. To apply our formula that the axis of symmetry will be the opposite of b over 2a, the opposite of -4 would be +4 over 2 times a, which is -1. 2 times -1 gives us -2, and 4 divided by -2 gives us -2. So our axis of symmetry is x equals -2. It's a vertical line right here. And then to find the vertex, that would be somewhere along this line when x is -2. So I'm going to substitute -2 in place of x. So we square it first. -2 squared would be +4. And then we're taking that +4 times this -1 out here. So we're getting -4. Then we'll do our multiplying. -4 times -2 gives us +8. -4 plus 8 gives us 4. 4 plus 6 gives us 10. So our vertex is -2, 10. So I'm going to come over here and plot -2, 10. Now I need to find two other points. So this is our vertex. We don't want to choose like 5 as an x value, because look at how far away that is from your vertex. So a parabola goes down or goes up very quickly. So as we get farther and farther away from that vertex, our numbers are going to get very, very small or very, very big, and we won't be able to fit them on our graph. So when you're choosing two more x values to evaluate in this equation, choose something close to -2. So first I chose -1. So substituting -1 in for x, squaring it first, -1 squared is +1, and then taking that times -1, we get -1. And then multiplying, -4 times -1 gives us +4, adding -1 plus 4 to get 3. 3 plus 6 gives us 9. So now we know we also have the point -1, 9. And so that was a number that's on the left-hand side, or sorry, on the right-hand side of our axis of symmetry. So also stay on the right-hand side. So I'm also going to use 0 next. So putting 0 in for x, squaring that gives us 0, times -1 is 0. -4 times 0 is 0. So we get 6. So I'll plot 0, 6. And then I'm going to take those 2 points that are on the right-hand side of the vertex. I'm going to reflect those across our axis of symmetry. So this first one is 1 unit from the axis of symmetry, so go 1 unit in the other direction. And then the next point is 2 units from our axis of symmetry, so we'll go 2 units in the other direction. And then we'll draw our parabola and include arrows on both sides. See ya.